give give a short introduction. Hello, everyone. I'm very happy to have Shomo Ganguly from University of California, San Diego here with us, and this is part of the effort that.
Hello
Cheenta.
everyone. I'm very happy to have Shomo.
Oops, I think there is a repetition. Okay, so Shomo is doing PhD. I think he's in the fourth year of his graduate program, right? And he has a very interesting background. He started with engineering. Is that right, Shomo? Did you start with
Yeah, I
engineering?
started with mechanical engineering in Shibpur.
And then you actually went on to study engineering in or something related to engineering in
Yeah,
UC San Diego, right? Is that correct?
yeah.
Okay. And then what the story he told me that he was attracted to mathematics in some class, and then he switched his PhD to a mathematics program.
Yeah, I'm glad you remembered this, but yeah.
No, it was a fascinating story, and I particularly remembered this because I remember that when I was doing my PhD in Wisconsin, one of the professors who just joined the like as an assistant professor in our university, he had a gap of like 5 6 years where he was working in the industry. He was working as a data scientist or something like that, but he came back, and not only he came back with some really strong results in topology and joined pure mathematics at that time.
Wow.
And this is very hard because once you're outside academics, it's very hard to sort of come back
Yeah,
in a
yeah.
way.
I mean, that is definitely more challenging, yeah, than what I did. But yeah, I was in academia only, but in a different subject.
Right.
Yeah.
So this the purpose of this video is to give a short introduction to a upcoming mini research series that Shomo will be delivering at Cheenta online. So I will ask Shomo to give a brief introduction to what he will be speaking about. But before he does that, let me tell you a little about what a mini series is entails to. So basically, what happens is it happens over 3 to 5 lectures. In case of Shomo, it will be 3 lectures, three subsequent lectures. Like it starts this Saturday at 10:15 p.m. IST. The Google Meet links will be shared in Chinta's website, as well as you can check the link in the description. We will we will also share it there. You can join the Google Meet link and join the live seminar. In the mini series, what really happens is you start with a topic in advanced mathematics, you build the necessary ground. So you basically teach the basics of that subject for 1 or 2 lectures, in some cases 3 or 4 lectures, and then in the final lecture or final 2 lectures, you discuss some new results that you have been working on, some research work that is your work or you are doing with your advisor or colleagues or whatever. So this is the idea of a mini series. In many universities of the world, researchers often give mini series. The first 1 or 2 lectures are actually very accessible. Usually, research seminars are not that accessible. Not that accessible means it can be really hard to follow what's going on. But in the mini series, first 2 or 3 lectures are usually very accessible, and we even encourage even excited school students to join it. I mean, we will. So, Shoma, please tell me a few things about this particular seminar.
Yeah, so as you said, that it would be a seminar of 3 lectures, and in the first 2 lectures, what I intend to do is to give a basic idea of, first of all, we know what complex numbers are, but often tend to do analysis in complex numbers with complex numbers. Like we do complex analysis, we do have complex differentiable functions and those things. But again, the picture becomes really, really different when you go to several complex variables, because there a lot of geometry comes in. So my idea is to build a geometric foundation in the first 2 lectures of the mini series, and in the last lecture I will actually talk about the thing that is the topic, which is the Cheng's conjecture. And I will so Cheng's conjecture was like a quite old conjecture in mathematics, in several complex variables, and it has been solved for domains and Stein manifolds, but for the two-dimensional time spaces I solved it completely, and now we are trying to solve it in other dimensions. But Cheng's conjecture is something that is fascinating, and it is fascinating because to understand this conjecture, you have to understand a lot of fields of mathematics. Like you have to understand Riemannian geometry, several complex variable, like normal function analysis, PDEs, and a lot of things. So yeah, so that's the idea. The idea is to deliver the background material in the first two lectures and then talk about advanced research level topics, which I hope will be somewhat understandable after the background has been laid, and we can talk about my results in the end.
I'm really excited to learn more about this. This is fascinating stuff, and Shomo is has solved a part of this big old problem, which is really exciting because you will have a sort of talk of that. So Shomo, thank you for this. I will see you on Saturday, and hopefully many people will join to hear what you have to say. Okay.
Thank you so much.
Yeah. Take care. Bye.
Bye.